weather check is not only an important part of your pre-flight planning, but is required for any flight not in the vicinity of an airport. A wide variety of weather reports and forecasts are available for pilots to use. Today, there are several ways you can access these reports and forecasts, including a personal visit to any flight service station, computer-based weather briefings, and weather reports by fax. Since the systems allow direct access to printed weather information, learning to decode actual reports and forecasts is just as important as ever. During this program, you'll become familiar with aviation routine weather reports, pilot weather reports, radar reports, terminal aerodrome forecasts or TAF, area forecasts, airmets, SIGMETs, convective SIGMETs, winds and temperatures aloft forecasts, and finally, notices to airmen or NOTAMs. Let's begin our discussion with a look at METAR, or Aviation Routine Weather Reports, which contain the latest reported hourly weather observations for various locations. The information for each reporting station is printed in a coded format beginning with the report type. Here, the word METAR represents a routine report. If SPECI is in this location, it indicates a special, non-routine METAR weather report, which means the report was issued at other than the regular time, and there has been a significant change in the weather since the last report. The next element contains the station identifier. Notice the METAR code uses the ICAO, International Civil Aviation Organization, four-letter station identifier. The stations within the contiguous 48 states are prefixed with a K. Here, KDEN is the identifier for Denver. Following the station identifier are the date and time in Zulu of the weather observation. When a report is generated by an automated weather observation station that has no human intervention, the word auto will follow the date-time group. If a correction is made to a report, the abbreviation COR is substituted for the word auto. The remainder of the printout is dedicated to weather, beginning with wind. Surface wind readings make up this section. The wind direction is given first, followed by the wind speed in knots. Here, the wind is blowing from 330 degrees at 18 knots. Variations of wind speed are shown as gusts and are indicated with a G. In this example, the wind is from 290 degrees at 30 knots, gusting to 45 knots. If the wind direction is variable and the velocity is 6 knots or less, it is noted by the prefix VRB. Here, the wind is variable at 4 knots. When the wind direction varies by 60 degrees or more, a variable group consisting of the extremes in wind direction, separated by a V, will follow the prevailing wind group. In this example, the wind direction has varied from 290 to 360 degrees. A calm wind condition is indicated by 5 zeros followed by KT. The next element of the METAR report gives the visibility in statute miles. At Denver, the visibility is 1/2 statute mile. When runway visual range is reported, it is preceded by an R. The next 2 digits are the runway number, followed by the visual range measured in feet. Here, the RVR for runway 31 is 2,600 feet. The next section of the METAR report is the present weather at the time of the observation. The type of precipitation or the obscuring phenomena is shown in code and may be preceded by an intensity symbol, a proximity code, and a descriptor code. Intensity levels are shown as either a plus or minus symbol and only apply to the first type of precipitation reported. This example indicates that light rain is falling. The plus symbol denotes heavy rain, and no symbol indicates moderate intensity. When the reported meteorological conditions are between 5 and 10 statute miles of the usual point of observation, the code VC is used, indicating the reported weather is in the vicinity of the airport. 2-letter descriptors are used to provide even more information about precipitation and obscuring phenomena. Here, FG indicates that fog is the predominant obscuring phenomena. Other common descriptors are TS for thunderstorms, SH for showers, FZ for freezing, DR for low drifting, MI for shallow, and BC for patches. The common letters used to indicate precipitation and obstructions to visibility include RA for rain, DZ for drizzle, GR for hail, FU for smoke, and HZ for haze. Additional codes are listed in your manual. The next block is used to report sky conditions. The amount of coverage is reported in eighths of sky cover and is represented by different contractions. If the sky is clear, meaning there are no clouds visible to the observer, the report will contain the letters SKC. At automated stations, the abbreviation CLR is used to indicate no clouds below 12,000 feet are detected. The letters FEW in the METAR report mean up to 2/8 of the sky is covered by clouds. A scattered layer, or SCT, means that the clouds cover 3/8 through 4/8 of the sky. A heavier sky cover is referred to as broken and is indicated on the report with the letters BKN. In this case, the clouds are covering 5/8 through 7/8 of the sky. When OVC appears, the sky is reported as overcast, which means clouds completely cover the sky. When the sky is reported as broken or overcast, a ceiling is said to exist. The height of the cloud bases are reported with 3 digits measured in hundreds of feet above ground level. Here, the first layer is a scattered layer at 800 feet, with a second overcast layer at 1,000 feet. When the sky is obscured by a surface-based layer, the vertical visibility is reported. The letters BV indicate an indefinite ceiling, and the 3-digit number is the height in hundreds of feet. In this case, the vertical visibility is 400 feet. Cumulonimbus clouds or towering cumulus clouds are observed. The letters CB or TCU will follow the number representing the height of the cloud base. In this example, the observer has reported a scattered layer of towering cumulus at 1,500 feet. The next segment of the report gives the temperature and dew point in degrees Celsius. When these temperatures are below 0 degrees Celsius, they are preceded by an M. In this example, the temperature is 10 degrees Celsius and the dew point is -8 degrees Celsius. Altimeter settings are preceded by an A and reported in a 4-digit format in inches of mercury. Here, Denver's altimeter is reported as 29.901 inches of mercury. The last section of a METAR contains remarks and is identified by the contraction RMK. This section includes operationally significant weather, as well as the beginning and ending times of the specified weather phenomena. In this example, rain began at 35 minutes past the hour. At 55 minutes past the hour, the rain ended. Pilot weather reports, or PIREPs, also provide valuable information about current weather conditions and should be reviewed in a thorough weather briefing. No other observations are more timely than the ones made by a pilot. In fact, PIREPs provide the only means of directly observing cloud tops, icing, and turbulence. A PIREP is usually received and transmitted in a prescribed format. The letters UA identify the report as a routine PIREP, and UUA identifies an urgent PIREP. 2-letter codes differentiate each block within the report. For example, OV describes the location of the aircraft. TM tells you the time when the report was made. FL identifies the flight level. And TP tells you the type of aircraft flown. These first 5 blocks must be included in all PIREPs. The PIREP must contain at least one of several weather elements, also identified by 2-letter codes. These include SK for sky cover, WX for flight visibility and weather, TA for temperature, WV for wind, TB for turbulence, IC for icing, and RM for any remarks that might be included within a report. In printed form, PIREPs appear in this format. This sample PIREP from near Centennial Airport was issued as urgent. The aircraft was on the Denver 161 radial at 14 miles. The time of the report was 1939 Zulu, and the pilot was flying at 11,500 feet in a Mooney Mark 20. The pilot reported moderate to severe turbulence between 11,500 and 14,000 feet while en route from Farmington, New Mexico to Centennial Airport. Radar reports are another important source of weather information since they identify areas of precipitation at the time of the report. Each report can be divided into as many as 10 blocks of information. The first segment contains the location identifier and the time of the radar observation. This report is from Evansville and was taken at 1926 Zulu. The observation shows an area of echoes with 3/10 coverage consisting of light rain showers, which are decreasing in intensity. The next segment defines the boundaries of the area of precipitation using the azimuth and range from the reporting site. In this example, the points defining the area of echoes are 338 degrees at 90 nautical miles from Evansville, 111 degrees at 110 nautical miles, and 262 degrees at 125 nautical miles. The report continues by indicating that the area of precipitation is moving from 260 degrees at 30 knots. Finally, it shows that the maximum tops of the clouds are at 12,000 feet, located at 324 degrees at 39 miles. The predicted surface weather within a 5 statute mile radius from the center of an airport's runway complex is called a Terminal Aerodrome Forecast, or TAF. Each forecast is issued 4 times a day and is valid for a 24-hour period. The codes used in a TAF are similar to those used in a METAR. In this example of a Terminal Aerodrome Forecast, you can find forecast wind, visibility if 6 statute miles or less, weather, and sky conditions. Let's take a look at a typical TAF. This forecast is for KDEN, Denver, Colorado. Following the 4-letter station identifier is the date and time of issuance. The first 2 digits are the date, immediately followed by the time in Zulu. This forecast was issued on the 9th of the month at 1745 Zulu. The next group indicates the valid period. In this case, the forecast is valid on the 9th of the month from 1800 Zulu through 1800 Zulu on the following day. The forecast is calling for winds from 220 degrees true at 20 knots. Visibility is expected to be 2½ miles with light rain showers. The ceiling is forecast to be 2,000 feet broken. When the wind direction fluctuates, or the wind speed is 3 knots or less, it is encoded as VRB. Cumulonimbus, CB, is the only cloud type included in a terminal aerodrome forecast. When the weather is expected to change during the forecast period, the TAF will indicate the change at the end of the report. For example, at Denver, from 0100 Zulu, the sky conditions are forecast to be clear through the remainder of the forecast. When a possibility exists for a change in the wind, visibility, weather, or sky conditions, and those forecast changes are expected to last less than an hour, they are preceded by the term TEMPO, or tempo. This report predicts that between 0400 Zulu and 0800 Zulu, visibility will drop to 3 statute miles associated with thunderstorms and rain showers. An overcast layer of cumulonimbus clouds with bases at 3,000 feet is also expected. BECMG, or becoming, is used when a gradual change in conditions is expected and should not last more than 2 hours. The forecast time of the weather is listed by a 4-digit number representing the beginning and ending hours of the change and follows the becoming indicator. When there is a 30 to 49% chance for the occurrence of thunderstorms or precipitation, you will see a probability group. Thunderstorms or precipitation expected to be present more than 50% of the time will be included in the prevailing weather or a tempo. Here, there is a 40% chance of 3 statute miles visibility along with thunderstorm and rain showers between 0000 and 0400 Zulu. This report also predicts that a broken layer of cumulonimbus clouds with bases at 3,000 feet is expected during this 4-hour time period. Now let's look at the area forecast, or FA, which also provides valuable weather information. Each forecast predicts the general weather conditions over an area the size of several states. You can use it to help determine en route weather as well as probable weather conditions at airports without terminal aerodrome forecasts. An area forecast is divided into 4 basic sections: communications and product header, precautionary statement, synopsis, and VFR clouds and weather. The communications and products header identifies the office issuing the forecast, the date and time of issuance, the valid times for forecast weather, and the states covered by the forecast. The precautionary statements, a standard note on each area forecast, indicate that thunderstorms imply possible severe or greater turbulence, severe icing, low-level wind shear, and IFR conditions. The statement in this example, see AirMet Sierra for IFR conditions and mountain obscurations, alerts pilots that IFR conditions and/or mountain obscurations may be occurring or forecasted to occur in a portion of the forecast area. Always check the latest AirMet for your area of flight. In addition, all heights not given in terms of mean sea level are noted in the forecast by the abbreviations AGL for above ground level or CIG for ceiling. This section of the area forecast is the synopsis, which contains a brief summary of the location and movement of fronts, pressure systems, and circulation patterns for an 18-hour period. This synopsis states that there is an upper-level trough in north-central Montana through southern Idaho that will move east into the plains by 00 Zulu with an upper-level ridge building over Washington, Oregon, and Northern California. There is also a surface high pressure over eastern Washington and northern Idaho that will build southeastward into southwest Wyoming behind the cold front. The VFR clouds and weather portion of this section is broken down by states or areas and describes the cloud conditions, weather, and/or visibility that are marginal VFR or better. In this example, Arizona is forecast to have scattered to occasionally broken clouds in the northern half of the state. The southern and far eastern portions of the state are expected to have scattered clouds with bases at 15,000 feet AGL and a chance of isolated light rain showers after 1500 Zulu. Included in the VFR clouds and weather portion is a 12-hour forecast and 6-hour categorical outlook for each state. The outlook for this area is VFR. When weather conditions warrant, the National Weather Service will issue in-flight advisories in the form of AirMets, SIGMETs, and convective SIGMETs. Although classified as in-flight advisories, these reports are also included in computer printouts. These advisories notify pilots of the possibility of hazardous flying conditions, which may not have been forecast at the time of the initial briefing. An AirMet describes areas of turbulence, icing, sustained surface winds greater than 30 knots, ceilings below 1,000 feet and/or surface visibility below 3 statute miles, and mountain obscuration of sufficient intensity or extent. There are 3 AirMet designators. Sierra always represents areas of IFR, Tango always represents areas of turbulence, and Zulu always represents areas of icing. Here, AirMet Sierra is valid for Wyoming and Colorado and indicates areas of mountain obscuration and IFR conditions. SIGMETs describe non-convective weather conditions of greater intensity than those in AirMets. SIGMETs are issued for severe or extreme turbulence or clear air turbulence, severe icing, dust or sandstorms that lower surface or in-flight visibilities to below 3 miles, or volcanic ash. Anytime weather conditions meet or exceed these criteria, or are expected to occur within 2 hours, a SIGMET will be issued. Convective SIGMETs report areas of severe thunderstorms, tornadoes, heavy precipitation, hail of 3/4 of an inch or greater, wind gusts to 50 knots or more, embedded thunderstorms, and lines of thunderstorms. However, since conditions of severe or greater turbulence, severe icing, and convective low-level wind shear are normally associated with thunderstorms, these conditions are assumed to exist and are not specified in the report. Convective SIGMET bulletins are issued at 55 minutes past the hour and are valid for 2 hours. Appended to each convective SIGMET is an outlook valid for 2 to 6 hours after the issuance time. This outlook discusses further convective development with emphasis on lines or clusters of thunderstorms and severe or embedded thunderstorms. Another element of your weather briefing is the winds and temperatures aloft forecast. This forecast helps you calculate en route speed and performance figures for your aircraft. Winds and temperatures aloft forecasts are derived from information gathered by weather balloons released at 12-hour intervals. The forecast gives the wind direction in degrees from true north, wind speed in knots, and the temperature in degrees Celsius for selected altitudes. Forecasts for specific locations are indicated by station identifiers. Each identifier is followed by code groups which show the wind direction, wind speed, and temperature at specified forecast levels. The first 2 digits represent wind direction in tens of degrees, with the next 2 digits representing the wind speed. Where appropriate, the remaining digits record the forecast temperature. In this example, the coded group forecasts a wind from 200 degrees at 6 knots. The temperature at this altitude is forecast to be 13 degrees Celsius. Due to terrain influence, wind forecast information is omitted from any level that is within 1,500 feet of the ground. Likewise, the temperature is omitted from the 3,000-foot level and any other level which is within 2,500 feet of the surface. Since temperatures are always negative above 24,000 feet, the minus sign is omitted above this level. Notices to airmen, or NOTAMs, are usually included with printed weather reports. NOTAMs alert you to recent changes in the airspace system that could affect the safety of your flight. Here, a temporary flight restriction is in effect until further notice. This restriction is due to dynamite blasting, and only authorized flights may be conducted within 500 feet over the blasting area. In this program, you have seen a brief overview of some of the major printed reports and forecasts that are available to you in preparing for any flight you take. When interpreted correctly, these reports and forecasts help you understand the weather you will encounter in flight.